Hello everyone, welcome to this video. We are going to run our first model. So to get started, you will want to download this file from the GitHub course repository and then upload it to Google Colab. Once you've done that, for the runtime type, I will use a CPU because this model / deep learning code is not too difficult to run. So we can get away with a CPU, but you can use a GPU if you want. Then connect to the runtime, go to runtime and then do run all. And this will take several minutes to run. As this is running, I will give a very high level explanation of what the code is doing. But because this is a high level explanation, I will skip out on large chunks of the code and focus on the parts that I think are important to know for now. So in our code, we will work with what is called MNIST. And in this chunk of code, you will notice that we have three data sets: a train data set, a test data set, and a validation data set, which I shorthand to val data set. What is going on here? I want you to imagine that our model is a high school student trying to pass a final test for their class. And in fact, for the rest of this video, I will refer to a model as a high school student trying to pass their final test in a class to make things easier to explain and understand. So what does this high school student have to do? Well, they have to study, right? So the trained data set can be thought of as the study problems and the study questions. And while our student is studying, it would be really nice if they had practice tests to study on as well, and so they can track their progress. That's what the val data set is. And lastly, we need the final test or the final exam itself. That is what test data set is. Here we can see that we are working with images that are 28 by 28 pixels, and these images are of digits. Most of these are pretty self-explanatory. This is a 7 and this is a 6. But some are less obvious. Like this is supposed to be a 0 because I put the answer on top. And hopefully, when our high school student finishes studying, they can correctly guess what these digits are. So here is the model. We have a nn.flatten to flatten the image from 128 to 784. We get this 784 by doing a 1 times 28 times 28. These two nn.linears that you see here, you can essentially think of as creating the weights for the model. And the nn.relu is an activation function, which I will explain later on in the course. Now we have a loss function, which is the error / loss part of our diagram. And we have an optimizer, which is the update weights part of our diagram. And this large chunk of code I have highlighted here is our high school student studying. So this is the high school student studying on the study problems and the study questions. And while the student is studying, they will work on the practice tests as well. And during the study session, I have a print statement so we can look at the progress. So at the beginning of the study session, the train accuracy is 88% and the validation accuracy is 92%. In regards to the loss, I will explain in more detail what loss is later on in the course. Let's focus on accuracy because I think that's more intuitive to understand. Then, by the end of the study session, we have a train accuracy of 98% and a validation accuracy of 97%. So, by updating the weights, we see an improvement from, look at validation accuracy, 92% to 97%. But even though our high school student is doing very well on the practice test, what ultimately matters in the end is how well you do on the final test or the final exam. And on the final test, our high school student gets an accuracy of 97.67%. Now, if I grab a random test data set or final test question, which looks to be a 2 and is actually a 2, here are the model outputs. Because remember that our model has outputs. The highest number is 8.59. This is at index 0, right? Or index 2, excuse me. This is index 0, index 1, and index 2. So the prediction is a 2. So now our model / high school student correctly predicts that this is an image or picture, etc., of a 2. And as this course progresses, we will revisit this file and go into further explanation on everything else you see here. Thanks for watching, and see you all in the next video.